Hello, my name is Greyson Marker, and I tested how the fabric denier, or thickness, affects how fast a parachute falls. The reason I chose this project is because parachutes are something that are very common. NASA uses them to help drop their rockets and their rovers safely on different planets, and the military will use them to help drop soldiers and supplies to different countries, and people can often just jump out of a plane with a parachute for recreational reasons, just to have fun. And we're also still learning how to perfect them, like what kinds of rope we should use, what kinds of fabric we should use, how big the parachute should be, what shape they should be. And I just thought it would be a really interesting thing to test how a small variable like the thickness of a parachute would, how much that would affect how fast it falls. The way I tested this was I took a 24-inch base template in the shape of an octagon, and I attached grommets about an inch away from the corner of each. As you can see here, there's a picture of me with a grommet gun attaching it to the corners, and I attached some string through it, and put a smaller grommet through, as you can see here, so that it would not go out. The string would not, the string would not fall out of it. And I used grommets in the first place so that it wouldn't actually tear through the fabric and ruin the experiment. And I added a 6-ounce weight to every single one of the parachutes to effectively test how fast every single parachute would drop. I then took the parachutes along with a bag and a long rope to the top of Flowers Hospital. It was about 81 feet high, and the weather was sunny. It was about 70 degrees and less than 5-mile-an-hour winds. I chose this day with these conditions because they were as mild as humanly possible, and then I could have the most accurate results without the wind affecting my drop times too much. There was a person on the bottom of Flowers Hospital on the ground level down here with a stopwatch, and I would drop the parachutes, and they would stop the stopwatch right as it hit the ground for accurate times. They'd then put it in the bag after I dropped it down, and I would bring it back up. I repeated this 10 different times for as accurate results as possible in case one drop was astronomically different than the other. What I found in the end was that the more I increased the denier of the parachute, the faster the parachute would fall. Well, as you can see here, in the average parachute fall times, going up is the time it took in seconds, and from left to right is the lower fabric denier to higher fabric deniers, my bad. And you can see a downward trend indicating that, again, as you increase the denier of the parachute, then the fall time decreases. Thank you.